this video, I'm going to dive into some statistical operations using CODAP. Some sample questions we'll be going over are here. We're going to explore the data set for 27 cases of mammals, including things like lifespan, height, mass, sleep, speed, habitat, and diet. In completing the statistics activity, we're going to be able to make graphs of these attributes. The attributes are otherwise known as variables or column headings in our table. So just go ahead and looking at these three graphs given to us, we can see that if we click on one of these dots, let's do lion. If I click on lion, our table automatically scrolls to this. And we can go ahead and see that each attribute is highlighted that we need to. So if I was looking for the speed of the lion, I could go down and see that that's 80. The other two graphs on here are lifespan and diet. So we see that that dot is still highlighted for lion. So that's going to be a lifespan of 15. And the diet's going to go ahead and be meat. And we see that the habitat is land with that coloring of the qualitative data. So back into this, if we are looking into creating our own graph, I'm going to go ahead and minimize this so we just have a little bit more room. And I'm going to go ahead and minimize these graphs as well so that we can create our own. So when making the first graph, we're going to go ahead and click on this graph icon. So as you can see, the points appear random, but they're still representing our data. So maybe we can try clicking on one of these points and see what happens to the table. So I clicked on the donkey, and as we can see, like I showed you before, it highlights on that table. Looking at this graph, we want to go ahead and organize our points. So to do this, we're gonna create a meaningful graph by labeling the axis, the horizontal and vertical axis, which represents X and Y. To do this, we are going to drag an attribute from the column heading to the table. So let's go ahead and grab height. We're going to grab it, we're going to drag it over here on the horizontal axis. So this is going to be our one variable graph. So as we can see, that donkey is still highlighted. If I go ahead and click away from that, it disappears. So looking at this graph, I immediately noticed that most of our points are on this side, which this represents our skewed right graph. So to figure this out, I can go ahead to the ruler and let's go ahead and see what our mean is for this data. So as we can see, the mean, if we hover over it, is going to be 1.86 meters for the height of these 27 animals. If I go over here and click our median, we can see it's going to be to the left, and it's going to be the 1.2 meters. So as we see in a skewed right graph, the mean is going to be to the right of the median, which is evident in this. So other things that we can look at are standard deviation. So we hover over this line right here, we get that standard deviation of 1.55 meters. So going into that, we can explore a little bit more. We can do a box plot of our data. So I'm going to go ahead and unclick these so we can just go ahead and see what we're looking at. So here's our box plot. As you can see, we have that quartile 1, quartile 3, and there's that median value. And here's our lower. So that lower is going to be our height. So we can look on here and find that if we want to. There we go. There's that lower. But I can also click on it, and it's going to highlight those lower values. And we're going to click on this. It's going to highlight these upper values and show us in the table. So let's say I want to see my outliers. I'm going to go ahead and click this Show Outliers box. So these are going to represent our plus signs that kind of deviate from that data. So I click on one of those. We're going to see it pop up right here. That's going to be our giraffe. So obviously that height's going to be 5 meters. They're very, very tall. We got another one that's going to be the killer whale. And that last one looks to be the African elephant. So those make sense, right? So going into this, I'm going to go ahead and get rid of our box plot. Let's see. And then we're going to go ahead and try and add another attribute to see how those band together. So let's go ahead and put mass in there. That's a good y value. So as you can see, this is going to be our independent variable because it's unchanging, and we're going to see how mass reflects height. So this is going to be our dependent variable. Mass depending on height is going to show us this graph. So if we wanted to look at it, we're going to go ahead and put in our least squares regression line. So that's going to give us that linear equation. I can move it out if I wanted to see that. I can also move this over, which is very helpful. So our squared value is going to figure out the type of correlation that we're looking at between height and mass. So we're going to see that that's kind of a moderate correlation, kind of lower. It's at 0.469. And then we get that equation for mass right there, based on height as our x value, which is very helpful if we're trying to solve some problems. So if I got a question that asked me, what was the mass, the average mass for these mammals in terms of this specific height? And as you can see here, we can have our count, which is not as helpful when we already have a count, but it just shows us that 27 mammals. So maybe let's go ahead and try another graph. I'm going to go ahead and click graph, and we'll do a different type of data, maybe something that's a bit more, whoop. Okay, well, I just drug that over. That already gives us a graph. So as you can see, we can do that. I don't even need this one anymore. So this gives us the order. That's more of a quantitative data. Oh, excuse me. I mean qualitative, because it's not a quantity, it's quality. But as we can see, there's different types of orders of the animals, and I can drag some of these over if I want to move them. They're not really partial. I can also go to this order and right click, and I can sort into an ascending order or descending order, or I can delete the attribute total if I wanted to. So I'm going to go ahead and sort this into ascending. So it starts with A, and it's going to be represented here on the graph. If I wanted to go ahead and show that count now, that is a little bit more helpful. So it gives us, so I don't have to count these individual dots. It's going to go ahead and give me 7. And we can show the percent over here as well. I'm going to get rid of that count so we can see it better. But yeah, so we can see that 26% of these 27 animals come from this type of order right here. I'm not going to try and pronounce it for you. But as we continue, I'm going to go ahead and get rid of this graph. But let me see if I can do another graph. And I'm going to make my own attribute. So I'm going to make this a little bit wider. And I'm going to go up here to this plus sign and add in an attribute. Let's say we want to see the average, I don't know, the average height of animals. So I'm going to go ahead and click this, and I'm going to edit my formula. So to do that, if we're doing average, obviously I'm going to take the mean of something, but I have to type in the specific attribute. So you can see that habitat pops up, height. So we want to go ahead and take height, because if I just typed in height myself, it wouldn't work. So I'm going to apply that. So then we can go ahead and see that average height. So I can drag this down here if I want to. So we get that average height right there. It's a straight line, obviously, because there's going to be an average for all of the data. So that makes it easier to compare to, let's say, the rest of the height. I can drag it right in here, and we can color point them. Obviously, that's not as helpful because I can't really see since the average height is kind of taking up that. But if I wanted to drag this height over here, we can see that difference a little bit better. So just getting into it, just to close up, some questions that we could explore that I came up with for my students would be to examine the relationships, that is spelled wrong, between the mammals' lifespan and their height, mass, sleep, and speed. So what you would do would you be go ahead and create your own graph, and obviously we'd go ahead and drag that lifespan to our y-axis because it's going to be our dependent variable. We're going to see how that lifespan is impacted by things like height and other stuff like that. So now we see that graph, and we can go in and get some other things, some points right there. We can change the view. I can display selected cases by selecting some of them. So let's say I wanted this first view. I could highlight it. That pops up as well. So that's how I'm going to figure out those trends that we see. So another question that we could explore into are the quantitative attributes compared to the qualitative ones. So obviously these are both types of numbers data. So if we go ahead and click on that, I'm going to take that lifespan out, and I'm going to compare the height of a mammal to its diet. I think that might be pretty interesting. And if I wanted to go even further, I can drag that habitat into the middle, and it's going to color code that like we saw before. So only one has both. That's going to be our gray seal, and we can see that height is pretty average. But I want to see something that's pretty interesting, is that killer whale. It does eat meat. The diet obviously impacts its height. We can also see that the habitat is in water for both of these, which is very interesting in comparison to meat, plants, and both. Okay, so overall, I just wanted to connect on that. So going over this task, I can identify that the math standard is going to be NC-M1 SID 0.6, which is representing data on two quantitative variables on a scatter plot and describing how the variables are related. So that's us finding out that linear formula and that R-square correlation. And then in this one as well, we're going to find that least squares regression line like we did for that linear data using CODAP. And we're going to use the fitted function to solve problems. So I could input one of these values into our linear regression line and solve for mass like I did before, or other values. I can also come up with different types of formulas if I needed to. So I'm going to go ahead and delete this one, but I can keep that and add in the other formulas if I feel like it. So that will be it. This was a relatively simple way to look at features working with CODAP and basic statistical calculations and graphs for analyzing data. Thank you for listening, and out.